Okay, so continuing with the discussion of benefits of layered models, we touched at one, breaking down the complex process of networking into layers with specific functions, making it easier to understand as well as troubleshoot. It also allows my developers or my engineers to concentrate on solving problems within a single layer. So my developers, I've already mentioned that they will focus on the application layer. My network engineers, they focus probably on the network layer going down. It's because of that breakdown and use of the layered model. Layering also allows isolation of problems. We've dealt with that one. Uh, Foster competition. I think some of the advantages or benefits, they are very closely related to the innovations dzakambotaura, interoperability dzatataura, pataintroduce some standards in standardization as well as competition. Since tese tiri kushandisa 7 layers, whether on iPhone, on itel, or on Negambuzi, communication wise, you are still going to use those same layers, same 7 layers. So interoperability tick, competition tick, innovation tick. Those are the benefits of using a layered model. Typical questions that you will get, you definitely get a question in my answers here. A question which what are the benefits of using my layered models? And you need to be able to identify okay, these are the advantages, benefits of my layered models. Right. Looking at the OSI reference model, right. Like I said, in a 7 layers, what I expect from you as a student is to know what is the function of each layer. I already mentioned as well what are the protocols that belong to each layer. So if I look at the application layer, it contains protocols used for process-to-process communication. That's a complicated definition for me. The application layer user interface. That is where the user interacts with the network. That's the best definition in application layer. That is where the user interacts with the network, the application layer. We have the presentation providing for common representation of data transfer between application layer services. To me, the presentation layer is responsible for data compression, for example, data encryption, data encoding to some extent. That's the presentation layer for you. Session layer providing services to the presentation layer and to manage data exchange. Session layer, it opens a session and closes a session. It initiates a dialogue and terminates a dialogue. If I'm having a conversation with someone, we have to initiate a dialogue. Hello, how are you? Probably ndomatangira kunoita makasimba here. Kana tapedza, bye bye. It means we have terminated the session. So there is a layer which is responsible for starting a dialogue, kana toda kuexchange a message, and ending the dialogue. Tichiziva kuti aiwa tapedza kusenda zvatoda kusenda. We have terminated the session. That is the session layer. We have the transport, which defines services to segment, transfer, reassemble the data for individual communication. Transport layer ensures transmission of our information. Dominated data segmentation, we've touched on that. Reassembling with the aid of sequencing, having my numbers, reassembling with the aid of sequencing. So the transport layer is responsible for that. The network provides services to exchange the individual pieces of data over the network. To me, that is where IP addressing happens. Who is the sender? who is the receiver, is done in the network layer. Which path am I going to take? The network layer chooses the best path to the destination network. Kubva panapa kunobata town CBD. There are many ways dzatinotora. Ndogona kupfuura nepaSouth Toll, ndogona kutenderera kuenda nekumbudzi uko kutenderera, ndogona kuenda nekugomo uko. Many ways that I can take. The network layer, if I can give an example, it chooses kuti path iri clear ndeipi, isina congestion, iri much faster to send my information ndeipi, pasina mapurisa neblock, ndeipi path iyo, using my network nema-IP addresses, network nema-host addresses. The network layer provides services to exchange individual packets. The best path to the destination. No network layers are in it. Data link describes methods of exchanging data frames over a common medium. If we are in a local area network, shared medium, we have the data link layer defining and not framing, data framing, my frames, exchange of my frames. It happens in the data link layer. MAC address. If you hear data link, think MAC address. Ndo network layer IP address. The physical, it describes the means to activate, maintain, and deactivate physical connections. My cables, I'm not on. The physical devices, I'm not on. You cannot see the electromagnetic waves. Okay, the air. My booster, I'm not on. My antennas, I'm not on. My boost. That defines the physical layer, right? The physical infrastructure which allows us to communicate. So in short, I usually say the application layer, if you want to understand it briefly, let me see. The application layer, user interface, interaction with the user. That's the user interface, the application layer. Presentation, we have encryption, data encryption, compression, and presentation, definition of the layer itself. How is data presented, right? Session, responsible for initiation and termination of dialogues, of sessions, of dialogues when we are communicating. Initiation, termination of dialogues. Transport layer, data segmentation, sequencing, plus sequencing, so that we have reliable communication. If not reliable, probably are using UDP. How is the data being transmitted from one point to another? The network layer, IP addressing. That is where IP addressing takes place. That's not my IP address. They function in layer number 3. We'll be talking of layer 3 and layer 2. These ones are very important. Layer 3 communication, IP addresses. Layer 2 communication, MAC addresses. In the layer 2, we'll be talking of MAC addressing, a MAC address. Then lastly, the physical layer is responsible for encoding all the information in Ruva, convert it into bits, which is the information transmittable over a channel. My bits can be converted to a voltage, to light, for fiber, to electromagnetic waves to be transmitted wirelessly. Yes, Lumuchena. Question? I'm listening.
All right. Sorry, ndatangobvunza kuti apa saka ndo panobva that nyaya classification yema switches kuti layer 2 kana kuti layer 3 switches.
Exactly. Ndopa zvinotangira ipapo. With layer 2 switches, a layer 2 switch is one which operates using MAC addresses only. That's a layer 2 switch. It has capabilities of data framing and only that. A layer 3 switch is sort of a hybrid. It can do data framing, perform at layer 2. It can also do IP routing. That's a layer 3 switch. So it's able to work at layer 2. MAC addressing is also able to work at layer 3 IP addressing. That's the difference between a layer 2 device, a layer 2 switch, and a layer 3 switch. A question, typical question you will get, you definitely get this one. Okay, my brain's that just switched off. But the answer to that question, we'll get to the question later. The answer to that question is router performer at layer 3 only. Switch performer at layer 2 only. We have a switch performer at layer 2 only. That's a layer 2 switch. So this is a router which performs at layer 3. Then we have another switch which does both. At layer 2, it switches. At layer 3, it routes. Door knows a layer 3 switch. Okay, right. So we have a layer 2 switch which operates uniquely at layer 2. We have a layer 3 device operating only at layer 3, it runs a router. Then we have a switch which operates in both those layers, runs a layer 3 switch. It's able to route. It's also able to exchange data frames with other devices. Going to the TCP/IP reference model, it's almost the same. Similarities are okay, comparison. The TCP/IP model ne OSI zvakada kufanana in the sense yekuti, let me explain it starting from here. In the sense yekuti these three OSI, they form the application layer TCP/IP model. So all the functions in layer 5, 6, 7 are the same functions, almost the same functions at layer number 4 TCP/IP. And as you can see, the transport layer is the same. The network layer and internet layer, they are almost the same. Then a combination of these two form the network access. The only difference between these two is application. This one is practical. This one is theory. And by that, this one, the theoretical one, it explains how does the network works, because it's theoretical. But what it explains, tikasvika paground tikati izvezvi tiri presentation layer, tiri papi network, it becomes very difficult to identify kuti tiri papi. Instead, with this one, I think the physical layer is very evident. The network layer is very evident. Theory-wise, very evident, but practicability, not so much. So this one is very practical in the sense that some of my protocols and their functions, they are being grouped, making it very practical. Comparisons, let me go through my descriptions. We did go through my descriptions. Applications represents data to the user, encoding dialog control. From the definition, we have the presentation layer already, which is responsible for this, and encoding as well. Dialog control, this is the session layer and OSI. So you can see the sum of presentation and session already. Right? The transport layer supports communication between is the same as OSI. The internet also almost the same, determines the best path through a network. That is IP routing. Then we have the network access controls the hardware devices and media that makes up the network, a sum of the data link and the physical layer. Comparison of those two layers. I think comparison is, we've already found the similarities. This is one of the similarities. This is one of the differences right here. Instead of having the application layer, we have application presentation session all coupled up to form the application layer. Rimwe rine 7 layers, rimwe rine 4 layers. I'm explaining this because I've seen a couple of questions in Noya about the differences or the similarities of the two models, which is not a big deal to me. The OSI model divides the network access layer and the TCP application in the application layer of the TCP model into multiple layers. The protocol suite does not specify which protocols to use when transmitting over a physical medium. The OSI layers 1 and 2 discuss the necessary procedures to access the medium in the physical means to send data over a network. Right. I think I'll need to explain this one a little bit more. OSI layer 1 and 2 discuss the necessary procedures to access the data and the media in the physical means to send data over a network. Right. Information by Novo. The TCP IP, it doesn't define this. Media access. Information by Nova Ogo. In case you are like all these layers are umsora. They don't even know what type of media is information going to be transmitted on. Is it going to be fiber? Is it going to be wireless? Is it going to be copper, coaxial, whatever that is? What knows is this layer runs data link layer. It defines how the media, what type of media is going to be used. Yeah, define the type of media, then the physical layer, it changes, encode, if I can say, encodes the information you have a hook, depending on which type of media has been identified. Then you encode you have transmit over the channel. So the OSI, theoretically, it defines all that. But can talk about TCP IP, we don't have that being simplified as it is. Right? Not much pressure here. Data encapsulation, I think we've already defined encapsulation, adding headers and trailers, adding a message on top of another message. We start with segmenting messages. Segmentation is the process of breaking up messages into smaller units. Multiplexing is the process of taking multiple streams to segmented data and interleaving them together. Segmenting messages has two primary benefits. Multiplexing, that's another advantage of breaking down a message. But at Tanga, we defined message size as one of the very important things Chatino protocols. And we said a long message needs to be broken down. Why could it be broken down? So that we can multiplex it. Multiplexing, joining messages that are under multiplexing, we can have 3 messages like this. Right? We can then multiplex them. My button is, if I can say, multiplex, so that we can transmit them over the same channel. Right? Tikasama multiplexer, it might mean we need 3 channels to send that information. Right? So segmenting a message, it allows us to break down the message, which allows us to multiplex, which leads to more efficient transmission of messages. Right, benefits, 2 primary benefits of segmenting a message. We have increased speeds. Large amounts of data can be sent over the network without tying up a communication link Increased efficiency, only segments which fail to reach the destination needs to be retransmitted, not the entire data stream. I think I'd explained that one. Instead of you sending the long message as a whole, if you break it down, one kapisi kakasasendwa kakasareceivwa, a response inongouya ichiti there is this message sequence number yakati isina kusendwa, please resend, ndo kanosendwa chete. We don't tie up the channel, if I can say, the link, the communication link, with unnecessary messages. We tie up the link with my message which really needs to be sent. So segmenting my messages, it has a couple of advantages: increased speed and increased efficiency. After we've segmented message yedu, there is need for sequencing. Sequencing messages is the process of numbering the segments so that the message may be reassembled at the destination. A protocol which is responsible for sequencing is TCP. UDP, the other one in the transport layer, does not have sequencing. So it means masvikira zvaita ndo masvikira zvaita iwayo. But with this one, information yedu kana yange inoda kusendwa ichiti 1 2 3 inofanira kusvika ichiti 1 2 3, and that defines what we call sequencing. Right, protocol data units, by definition, let me see, encapsulation is the process of adding information. Let me remove this. Hide video panel. Right. Encapsulation is the process of. I have something blocking my view here. Just a minute. All right, go. Encapsulation is the process of. Is the process where protocols add their information to the data. Right? We've defined that. Now we want to define the PDU, protocol data unit, a specific unit of data used in exchange, a specific unit of data that is exchanged at each layer of the OSI model. A specific unit of data that is exchanged at each layer of the OSI model. All right, a PDU. So the OSI model yedu 7 layers, starting with the one the application layer. The PDU is the unit of data. We give it a name. Kana tiri application inenge ichinzi data. The message plus whatever added information iri application layer makes up yatinoti data. Right? Parinodzika session, rodzika presentation, rodzika session, it's still called data. That is the PDU. Tikati PDU for the application layer. Kana taku TCP IP, the PDU is data. That is the unit of data that is exchanged. Tichibva ku-application. Tikadzika, encapsulation occurring. We add information yepa layer number 4, which is the transport layer. Patinoaddera information yepa transport layer, tambo explainer tikaedera kana tiri kudzika kudai tichaedera header or tichaedera trailer rem transport, tichaedera header rem transport. Painosvika panapa tichiedera matrailer nemaheaders rem transport, the PDU is now called a segment. We now know what a segment is. Then patinodzika kupinda layer number 3, tinoedera maheaders nematrailers em layer 3, which contain the IP addressing information. Now that information yachinja PDU, rakunzi a packet. Yodzika, we add MAC addressing information, rakunzi a frame. Radzika, frame iroro ndo rinoconvertwa into my bits, which is the digital information which we can use to transmit our signal. So the important thing to get out of this, if we are in the application layer, we call the information data, a data stream. Kana transport, that information is called a segment. That same information with the addition of my headers and my trailers after encapsulation. Kana panapa, network layer, tinenge takutaura nezvemapacket. Kana second layer data link, takutaura nezvemaframe, and this is the physical. So going forward, if we are talking about a frame, we are talking about layer 2, trim layer 2. If I'm talking about exchange of frames, it means exchange of information in layer 2. Ndikatanga kuti exchange of data packets, it means exchange of information at layer 3. Takuinclude my IP addresses. Can keep a layer 2 to MAC addresses. If I'm talking of a segment, I'm talking about information in the transport layer. And if I just say data, we're talking of information in the application layer. So, do I say that data is because we're in the application layer? That is what you're interacting with. That is what you send. You send data. But in between the recipient and the sender, that data is changed to a segment, it's changed to a packet, to a frame, and then to a bit stream, which is sent over a channel. Where as a recipient could you receive it, that bit stream is changed again to a frame, then to a packet, then to a segment, up until we get the data again. And that is what summarizes a PDU. Encapsulation is a top-down process. The level above does its process and then passes it down to the next level of the model. This process is repeated by each layer until it is sent out as a bit stream. I think we've gotten through that. Encapsulation, top-down, application. So application layer, trace a header. You get what application plus presentation because nobody need data plus session. Tupinda panapa, trace my header transport to Zika. Trace my header network to Zika. Trace my header data link to Zika. Trace my header physical. Kanatashka panapa, we have a segment. Kanatashka panapa, packet. Kanatashka app, frame. Kanatashka app, yeah, bitstream. Kanatashka send the information is top down. Information kana shika kwa rufana kuenda. Receive yanoitwa inoreceive from the bottom up. Inoreceive as my bits. Then you have convert into a frame. My frame per frame, my headers of this called de-encapsulation. You have query. My headers a network layer of this called. You have query. Information about transport of this called. You have query. Painosika kuno kunengera data. And data is what us as humans are able to interpret. Us as humans. Screen ramakatarisa information that's data. In between, ring frame, ring packet, ring segment, etc., etc. Decapsulation, I think we've already touched on this one already, is the opposite of encapsulation. Data access addresses. Both the data link and the network layers uses addresses to deliver data from source to information. Data from source to destination. Right. Addressing is very crucial in networking. My protocols pane zvaari kuita in a network, that's very important. But without knowing good information, iri kuenda kupi or yabva kupi, will not be able to 10 minutes. Okay, we'll be done. Will not be able to send that information. That's why addresses are very important. So addresses are crucial for the following. One, unique identification of devices. It identifies my devices in a network. They are also used to determine the best path to route my packets. Routing, choosing the best path. Paths to a destination network. There can be many. Right? But the best path is chosen because of knowing what are the network addresses that inazo in a network, what are then the host addresses that inazo in a network, allowing us to choose whether this is the best path that we're going to choose. Right. Another one, data delivery to correct destination, obviously. Kana pasina address, how do you know the recipient of that information? So addresses are very important briefly. Two types of addresses that we have. We have the network layer address, that's the layer 3 addresses. We have the data link layer addresses, layer 2 addresses. My layer 3 addresses to know my IP address, responsible for delivering the IP packet. Start noticing the UCIMA weather packet, PDU, network layer, layer 3 packet. Data link, layer source destination and source and destination addresses responsible for delivering the data link frame. Start noticing the UCIMA words you are very important going forward. Responsible for delivering my data frames from one network interface card to another network interface card. So two types of addresses that we mainly have. Layer 3 addresses. My layer 3 addresses, we have the source and the destination IP. Source, in this example, source, final destination. Source, ndokurukupa information, we identified using this IP address, and server we identified using that IP address. And the packet zvarinenge rakaita and its format rinenge rine source IP rine destination IP, then kunoku ndokunenge kune data rako, data rabva kuapplication riya, and this will define what we call a header. Kunoku kunenge kune trailer, there's another chiriko trailer inenge iriko this side. So is this part here show up is part of the header YAML layer 3, showing the source and destination IP address. Layer 3 logical addresses, right? Network portion, host portion. An address, it has two parts. I'm not going to focus much on IP addressing for now, but we have to know in a two parts. One, the network portion, which represents the leftmost part of the address, indicates the network group which the IP address is a member. Each LAN and WAN, we have the same network portion. Then the host portion is the remaining part, which is unique for each device on the network. Is there an example? Right, perfect example. The network portion from addresses to Arapa, APC1 FTP. This is the network portion ish. All right, which is the same NE because they're in the same network. So we are looking at PCE Irapa and server Irapa. Since router interface iri, this is the same network Irapa. They are in the same network, meaning the prefix will be the same. Panapa Tanzi, the leftmost part of the address indicates the network group, which the IP address is a member. Each LAN will have the same network portion. So LAN E in the same network portion, meaning the prefix, these first three digits, they are the same. So an address, an IP address, in the network portion and the host portion. Then we have the MAC address. The MAC address is another type of address that we use to identify my devices in a network. All right, when devices are on the same Ethernet network, the data link frame will be used. We'll use the actual MAC address of the destination NIC. MAC addresses are physically embedded into the Ethernet NIC and are local addressing. The source MAC will be of the originator, the destination MAC will always be on the same link as the source. Right? MAC address is another type of address in a physical device. It identifies the physical device. The difference between MAC address and IP address, for example, the Kabinam network, my MAC address will always be the same because it's embedded per device. However, IP address can change. The Kabinam network, if I get assigned an IP address in the DHCP, ndikabuda munetwork mumwe munhu akapinda anopiwa that same IP address, angonopiwa that same IP address. But does it mean is that same person? Zvinoti nini ndikapinda nelaptop yangu munetwork ndopiwa IP address, ndopiwa for example ndopiwa IP address ishi, MAC address yangu iAAA, ndobva ndabuda munetwork neAA yangu, popinda mumwe munhu ane BBB MAC address, anogona kupiwa the same IP address neDHCP because that IP address is no longer is available. Hapasisina a device iri pa-IP address. If you send information thinking kuti is the same PC iri kusendwa, you'll be wrong because PC yapo is a BBB instead of AAA. So the difference between my MAC addresses and my IP addresses is in that. Zvekuti kuti unyatsoziva kuti uri kusendera which device specific, you need to know the MAC address. If you use the IP address only, there is a chance you can also send information to the wrong recipient. So we'll learn that my MAC addresses, they are local addresses in the sense that they only work in a local area network, right? Meaning, if I want to send information from this PC to this server or this other PC, I can communicate using my MAC addresses because I'm in the local area network. However, I can communicate with a server really remote. That is where the layer 3 addresses takes over. Locally, MAC address is okay. Remote, layer 3 addresses take over. However, even if layer 3 addresses take over, could use a specific address your sheets and the location your sheets information, you need to know the MAC address. That's why we have more protocols like ARP address resolution protocol. Inenge yakakumirira uchisvika panapa neIP address. Uchisvika panapa protocol robvunza kuti ndine IP address yakati. What is the MAC address? The ARP protocol. Iyo respond kuti MAC address yangu yakati. Then information kana yakusendwa inoenda yakazara ine IP address neMAC address. Yobva yachizosendwa to this specific device. If there is no response, yekuti MAC address iyi, IP address yatinayo iyi, MAC address ichi, then no message will be sent. So in summary, two types of addresses that inazo. One is used locally. It works locally. The other one, inoshanda remotely, which is the IP address. Right, devices on the same network and devices on remote networks. If my devices are on the same network, let's say I'm trying to send, will I be able to finish here? I think I'll need 5 extra minutes because this is very important, very. If I want to send to a device on the same network, right, let me continue, less than 1 minute. I think it's stopping anytime soon. 3-4 minutes will be enough to, because I think this is the end of the slide. 1, 2, 3, 4, 5. Yeah, 5 minutes. Okay, 5 minutes. Let's end with the 5-minute session. I think it will be enough to finish. Because this is very important. Understanding my MAC address is what? My IP address. So log in again. Ooh.